So before I tell you about a binomial distribution, I need to tell you about a probability distribution. And we talked a little bit about probability yesterday. Tell me what you think probability means. Without using the actual word. The chance, right? The chance of something happening. And we talked yesterday that to find probability, we make a ratio. We do the possibility or the possible outcomes over the total outcomes, right? So if we want to know, if you have, like on your quiz, the number of 5-card hands that contain 4 kings and 1 other card, and it was 48. So if you have 48 possible hands that are made that, but then there's 2 million total 5-card hands, and the chances of getting that would be 48 out of that 2 million, right? So we make a ratio out of it. So what a probability distribution does, a probability distribution, is it lists all possibilities with their probabilities in a nice little neat table. In a table. So if it lists everything, then your probabilities should all sum to what? 100%, right? Or a 1. Because it's, y'all see that? Yeah. Because it's every possible outcome listed in the table. All right. So let's say, for instance, not my favorite thing to teach. Okay. Let's say you have 2 dice. I'm going to use the example in the book because it's just easiest like that. Let's say I have 2 dice. 2 dice. How many sides does a die have? 6, right? 1 number on each side. I want to construct a probability distribution table of all possible outcomes of the sum of the 2 dice when they're rolled. Okay? So what could those possibles, and for the sum, I'm going to let the sum be represented by x. Okay? So I'm going to say x could be this down here. P of x is going to be the probability of x. Probability of x. So tell me, what are the possibilities? What could x possibly be? If x is the sum when I roll the 2 dice, what could I possibly get? 2 is the smallest I could get. Okay, let's go in order. But you're not wrong. You're right. 3 up to what? 12. Why can I not have 1 on here? You've got 2 dice, right? 10, 11, 12. So now the question becomes, what's the probability of rolling a 2? Well, what are all the different scenarios that could occur? I should probably put this on here so you have it on the video. I'm coming back to that chart. Possibly. All right, so for the first die, I could have 1 through 6, right? It could be a 1, it could be a 2, a 3, a 4, a 5, or 6. Now, when the second one comes up, if the first one's a 1, the second one could be a 1, 2, 3, 4, 5, 6. Do you agree? If the first one's a 2, then the second one could be a 1, 2, 3, 4, 5, 6, right? And so on and so forth. Do you see what I'm doing here? But I'm talking about the sum, right? So these would sum to 2, 3, 4, 5, 6, 7. 3, 4, 5, 6, 7, 8. Do you see the pattern here? 4, 5, 6, 7, 8, 9. 5, 6, 7, 8, 9, 10. I'm going to have to go over here because I'm in the room. Yes. 6, 7, 8, 9, 10, 11, or 7, 8, 9, 10, 11, 12. Those are all my possible outcomes. Do you agree? There's not, I have, essentially what I've done is I've listed every combination. Rather than doing 7, choose 3, I've listed every possible combination that could occur if I roll 2 dice. So now, let's go back to the probability chart. Okay. So the pink numbers are dice 1, dice 2. The green numbers are what happens when you add them together. So all the possible sums, yes, it goes from 2 to 12, but some numbers are repeated here. Okay. So, how many possibilities, total possibilities, can you get? Yes, there's 36. Yes, there's 36. There's 6 outcomes per each big pink number, and 6 times 6 is 36, right? Okay, so there's 36 possibilities. So my total possible is going to be 36. That's going to be my denominator of my fraction each time. So now the question is, let's fill in the table. We said 2 was the smallest possibility. How many times does 2 occur? 1. So the probability of getting a 2 when you roll 2 dice is what? 1 over 36. How many times does 3 occur? So the probability of getting a 3 is? We're going to leave it right like this right now. You can simplify and you would simplify, but right now I want you to see that the probabilities are all going to add to 100%. So I want you to, yeah. How about 4? How many times does 4 occur? Count them up if you don't know. Look at the list of green numbers and count how many times 3 happens. It will until you get to a certain point. How about 5? How many times does it occur? 4. How about 6? 7? 8. Ooh, good job. 9. 10. I hope you are noticing the symmetry here, right? It's the same, it peaks at one time. If you were a betting person and someone said, put your money on a sum 2 through 12, what would you put your money on? Why? It's the most probable. It's the highest probability. It is most likely that when you roll 2 dice, you're going to get a sum of 7, either a 4 and a 3 or a 3 and a 4, right? That's the most, or a 6 and a 1, or a 1 and a 6, or there's just more ways to get 7 than there are any other number on there. Does that make sense? Now, huh?
There's this board game that I have that's like it's called Pitch for One. Whatever, you build like settlements and all these like different things. And you roll dice and whatever, like say that lands on like the 8, if you're roll settlements on the 8, then you get like.
Is it just one die though?
No, it's 2.
Oh, it's 2.
And it's based on probability. Like, so you want to put your 35.
Well, now you know the most probable. There you go. The Yahtzee pros. Okay, so a couple things. This is what we call probability distribution. It lists all the probabilities. Now, in a probability distribution, there are a couple of requirements. Okay? Distributions. One, all probabilities must be positive. You can't have a negative. There's not a negative 1 in 36 chance that you roll a 7. It just doesn't happen. So all probabilities are positive, and all probabilities sum to 1 or 100%. I don't have them in percent form here. I just have them in decimal form. Do those sum to 1. They're all over 36. I didn't simplify any so you could easily see. 1 and 2 is 3, and 3 is 6, and 4 is 10, and 5 is 15, 21, 26, 30, 33, 35, 36. Okay? 36 over 36 is 1. Now, we also graph these. I was waiting. No, I'm serious, unfortunately. It's an easy graph. No, it's part of this lesson. When we graph them, it's a really, really, really easy graph. We use a histogram to graph. A bar graph. If you add everything up in the probability row, it'll add to 1. 36 over 36. Guys. All right, so when we graph, here's what we do. This is my x, which is my sum in this case. And my probability goes on the y-axis. Okay? Now, my probability, the biggest it goes up to is 6 out of 36, right? Right. 1, 2, 3, 4, 5, 6. This will be 1 out of 36, 2, 3. I hope you all can do a bar graph or histogram. So this will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And now you just graph each one corresponding. So 2 goes up to 1 over 36. Put a 1. 2 goes up to 1 over 36. 3 is 2 over 36. 4, you see what we're doing with this? 5, 6, 7, you should be able to look at it and clearly tell which one is your most probable. It's symmetric, right? Do you see that it's symmetric? Yes, conspicuously see. Good. I'm so glad y'all see. Okay, so the middle bar is the tallest, which means it is also the most probable. Okay, so just given that, it's easy to look at it and say, oh, look, that's the most probable. That's where my money goes, right? All right. They need to touch. Tell me this, looking at this distribution, either at the graph or the probability distribution table. What is the probability that you roll at least an 11? 3 out of 36. At least 11. Think about what that means. At least 11 means 11 or 12, and we know that or means you add. So it would be 2 out of 36. And this is why I left them unsimplified, because it's a little easier to work with as you start to do things. What's the probability that you roll no more than 5? No more than 5. 10 out of 36. 10 out of 36. You see what we're doing? We're just adding them. Does that make sense to you? Can I what? All right, so binomial has a couple of requirements before it can be considered binomial. I hope one of them you can guess.
It has 2 things.
Two, okay? There are 2 outcomes, okay? A pass or a fail, a yes or a no. I'm trying to think of one right off. Let's say, what's the probability that you live in a house or you don't? You either do or you don't, right? Well, I mean, you could live in a trailer, you could live in a camper, you could live in a tent. I'm just saying. So it's yes a house or no you don't. You see what I'm saying? There's only two outcomes. The other thing is each one you look at, each person has to be independent of the other. And what that means is the fact that Chandler lives in a house would not impact whether or not Mary lives in a house. They're independent of each other. Okay? Each event is independent. Okay? Also, the probability of, I'm going to call it failure. I don't really like that, but it's well, a lot of times they use success versus failure. You know, it's yes or no. So the probability of no, or the probability of failure, or the probability of it not occurring must be 1 minus the probability of success. So if the probability that you don't live in a house is 60%, then the probability that you do has to be 40% for this to work. Okay?
So it's not like crazy when it's like 500.
No.
I never.
I don't understand that. I feel like stock prices have reached like 500, 900.
How does one
They've-
equal 100? How does why is it 1 minus
100%.
100% or 1. If you just
If you
left it
got
as a
one
fraction,
problem on your test
like,
right out of
oh,
100,
so
you
this
got
is
100.
Paula, what is 100%?
no.
Oh my God.
All right, but 1 minus 0.6 is 0.4, or 100% minus 60% is 40%. Some examples of binomial distributions that you're probably a little more familiar with would be the probability of you randomly guessing on a multiple choice test. You either get the answer right or you get it wrong. The probability of success depends on how many options you have, right? 4 options if it's A, B, C, D on a multiple choice test. And we'll do several of these examples because it's really interesting. You got a 25% chance on each question, so your probability of success is 0.25, right? Probability of failure would be 0.75. And depending on how many questions you have, your probability changes, okay? And we'll do a couple of those. But that's binomial. It's yes or no. You flip a coin 100 times, the probability that you get 25 heads. That's yes or no. You get a heads or you don't get a heads. Those are binomial probabilities, okay? And we're just really scratching the surface on probability. But it's cool because a lot of people don't take prob stats here, and that's sad, but yeah.
Got freaked out.
Well, I mean, because that's, of course, the track you're on, but... So, yes, there is like a formula. Y'all are going to love it.
Oh,
This is
sorry.
like you won't be able to tell I cannot. I can't. It doesn't. I never was able to learn this.
All right. This looks worse than what it is. Okay.
Really.
Let me define some variables here for you. N is your total possibilities, okay? If I've got a 25 question multiple choice test with 4 answers each, then my N is 25. There are 25 different scenarios, okay? Different times that it happens. K is the number of successes that you want. I want to know the probability of guessing exactly 10 questions out of 25 right. My K would be 10. My N would be 25. Okay?
For the whole problem. All the answers.
Yep. P, now if I wanted to know the probability of success of like passing the test is 70, I would have to do getting like 20 right, or 21, or 22, or 23, and I would have to add those probabilities together. No, we get, oh, yep. All right, P is the probability of success. Okay, 4 options on a multiple choice question, then it's 0.25, right? And then, of course, 1 minus p would be the probability of failure. So let me show you one quickly because I did not know we only had 5 minutes left. I'm just getting so excited. Huh? That's failure.
This would be you're gonna come to Distrbution.
I'm teaching today.
You're teaching today.
Like after school.
That's what you're looking for. They'll say, what's the probability of getting 10 questions right out of 25? Your K would be 10, your N would be 25. All right, let's take a look real quick. Shh, yeah. Let's do the same thing we've been doing. I might have y'all just a little bit after the bell. I'm sorry if I do. Y'all just stay with me just a second. You're taking a test, right?
Yeah.
Guys, y'all stay with me. 25 questions. Multiple choice, 4 options for each question. Okay, A, B, C, and D. Most of the time I throw an E in there because I'm mean like that. But we'll just do A, B, C, and D, okay? I want to know, first of all, do you understand why this is binomial? Okay, it's right or it's wrong. You guess right or you guess wrong. There's no in between, okay? It's one or the other. You getting question number 1 right is not impacting you getting question number 2 right. They're independent. Okay, I know. You're getting it. Okay, what's the probability that you randomly guess at least 20 questions right?
0.005%.
No. We're going to have to use that formula, okay? That NCK. All right, so here, N is 25. K, that's how many I want, is 20. What's the probability of success for each one? 0.25. So then 1 minus P would be, so that's the probability of failure, right? So the probability of getting just 20 right would be 25 choose 20 times 0.25 to the what power? 20th power times 0.75 to the what power? 5. Subtract these two numbers to get that, okay? That's the problem. It's going to be a terribly small number because the chances of you randomly guessing 20 right out of 25 and there's only a 25% chance for each one is really, really low. Now, on your homework, you're going to set up a probability distribution for this where you'll list all the possibilities. So it won't be one that's 25. That was just for the sake of example. But if it was, you do 0, 1, 2, 3, 4, 5, all the way up to 25. And that's what you'd be plugging in for your K. All right? And then you'll use that to analyze some more questions. All right, let me give you your homework.